Good afternoon, everyone, and welcome to this lecture. We are dealing with simple harmonic motion, and I think in the previous lecture we were dealing with the various terms of simple harmonic motion. We had dealt with
Phase between displacement, velocity, velocity acceleration, and displacement acceleration.
we were seeing the relation between, we were seeing velocity and acceleration as a function of time. We had also seen velocity and acceleration as a function of x. We have seen those graphs. Graph between v and x, position or displacement, is an ellipse, whereas the graph between acceleration and x is a straight line. It's negative of that is minus omega square times the displacement. And then we had also seen who is ahead and who is lagging and so on. That is what it is there. Now, to understand who is ahead and who is lagging, let me start with that ahead and lag. What do you mean by this ahead and lag? So lagging, leading and lagging, SHM, you can write this heading: leading and lagging waves. Leading and lagging waves. Remember, all these are equations of a wave, because that is our next topic that we are going to deal with. This is also a wave equation of a simple wave. We'll see that wave. This will also come in wave optics, leading and lagging. What do you mean by this leading and lagging? Leading and lagging. Suppose you have two equations. X is equal to a1 sine of omega t plus, let us say, phi 1. And let us say the second displacement or second position is given by x is equal to a2 sine of omega t plus phi 2. These are the most general types of equation that you will come across. Now, knowingly, some things here have been kept same, and some things here have been kept different. What do you see is same, and what do you see is different here?
Sir, angular frequency is same and time is same.
Time is not same. Time is a variable, Kade. Time is a variable. Time is not same.
I
It's
mean,
given as a function of time. So time is not same.
the
Given
delta
as
t is same.
huh?
Delta t may be same, no, sir.
What all things are different and what all things are same? The amplitudes of the two waves are different. One has an amplitude of A1, the other one has an amplitude A2. The phase of the waves is different. Do we understand this? They have different phases.
Yes, sir.
Omega, which is the angular frequency, is same. So angular frequency is same, but the phases are different. Now, instead of writing this equation in this fashion, I could have written this like this: x1 is a1 sine of omega t, and x2 is a2 sine of omega t plus phi. Same thing, but I've just omitted phi 1 and phi 2 just for you to understand. Now, when I look at these two motions or these two waves or these two equations, they are not in the same phase, and we know how to find out the phase difference. Yes or no? I subtract the phase of the first one from the second one, or the second one from the first one. Now, when you have this equation, and it is very easy to see that they are not in the same phase. One of them is leading. When I say leading, it is ahead. One of them is lagging. When I say lagging, it is behind. Now, what do you mean by leading wave? Leading thing is the leader. If these are two pens and this is the leader, so whatever a leader does, he will do everything first, and this whatever is behind this will do everything after this leader has done. That is what a race is all about, and that is what leading and lagging waves is all about. Whenever we say a wave is leading, it is ahead. It will do everything before the previous one, before the one that is following it. Now in these two waves or in these two equations, you see one of them as leading and one of them as lagging. Which is the leading one and which is the lagging one? Who is
X,
ahead?
X2 is leading and X1 is lagging.
So this X2 wave is leading and this X1 wave is lagging. So that is what you understand by the meaning of the term leading or lagging. Now, if I may ask, with how much angle? With how much angle is it leading or with how much angle is it lagging? So what is the answer? Or with how much angle it is leading or lagging?
Pi, sir.
Phi. X2 is leading X1 by a phase angle of phi, or X1 is lagging X2 by a phase angle of phi. Do we understand this? Huh?
Yes, sir.
Now, this leading and lagging becomes simpler to understand if both the waves, either they are in the form of sine wave or they are in the form of cosine waves. Now, if one is in the form of sine and the other one in the form of cos, we might have a trouble then. Well, how do you compare this? Now, if I talk about SHM, x is equal to the position or the displacement is given as x is equal to a sine omega t. Velocity, when I find it out by differentiating it, is a omega cos omega t. Now, how do I find which one is leading and which one is lagging?
Sir, we can convert x equals to a sin omega t to cos omega like that, or we can convert a omega cos omega t into a omega sin omega something.
Right. So that is what we are going to do, because velocity comes from the derivative of displacement. So that is how we understand it. So what are we going to do here is we are going to write this in this fashion. V is equal to a omega. Now, how do I convert it? The only way that is fruitful is converting it like this. Do we understand this, or this has gone above our head saying bye-bye?
Understood, sir.
Now you understand who is leading and who is lagging. Who is leading and who is lagging?
V is leading and x is lagging, sir.
By how much angle?
Pi by 2, sir.
Pi by 2. And that is what we had written in the previous class. You understand this or bye-bye?
Understood, sir.
Now let us move on to acceleration. Acceleration is minus a omega square sine omega t. How should I write this? Huh? Don't write, sir. Why to write, sir? Huh?
Sir, that minus should be converted.
How?
Like sin pi plus omega t.
So I can write this acceleration is as a omega square sine of omega t plus pi. You understand this or this is gone above saying bye-bye? Huh? You understand this?
Understood, sir.
So now we understand this acceleration is ahead of the displacement by a phase angle of pi. And that is what we had written in the previous class. Who is ahead, who is lagging, and that is how we find out who is ahead and who is lagging. Everyone understands this?
Yes, sir.
I'll give you a minute to note it down. Note it down, let me know. Okay, now since we have understood what is a leading wave and what is a lagging wave, you may be able to give me or tell me what is happening here. This is a blue wave. This is the green wave. Okay, I could not draw it properly, but I hope we have understood the concept. Now the green wave starts from here. The green wave starts from here. Okay. Let me try to make it correctly. If I take this out, okay. It will go like this. It should go like this. Okay, since my hand drawing is not so good, you can see a lot of difference between the initial thing and the final thing, but I hope you understand the concept that I'm going to tell you. Okay, if this is 5, this is also going to be 5. I could not draw it accurately, but I hope you understand the concept. You understand, Nina, what I'm trying to do it here?
Yes, sir, we understood.
Now, what will be the equation of this blue wave? It should not take rocket science to tell me that.
A sin omega t.
X is equal to A sin omega t is definitely the equation of this wave. Now, can you tell me what is the equation of this wave?
X2 equal to A sin omega t plus phi.
Okay, if I call this as x1 and if I call this as a1, x2 becomes, this second wave becomes, x2 becomes a2 sine what?
Omega t plus phi.
Omega t plus phi. Anyone understands this?
Yes, sir.
Yes or no?
Yes, sir.
That is wrong, sir. It is not omega t plus phi. It is not omega t plus phi. Then what is it? It is omega t minus phi. Why minus? You have to understand which is the leading wave and which is the lagging wave. Which is the leading wave here? Huh? Which one is leading?
Blue, sir.
Why blue? Because this blue wave is doing everything first. It reaches the mean position first. Green wave reaches here, but reaches here after a phase angle of phi. The blue wave reaches its maximum position on the right side, extreme position on the right side first. The green wave follows it after a phase angle of phi. So which is leading, which is lagging? Blue one is leading and green one is lagging. Do we understand this?
Yes, sir.
So this is the same thing that we have written in the form of equation. The same thing explained in the form of their sine waves, in the form of their diagrams. We understand this? Yes or no? No, yes. Huh?
Yes, yes, sir.
We shall go on above it saying bye-bye.
We understood.
Pakka?
Yes, sir.
Are you noting it down?
Yes, sir.
The concept of leading and lagging. Note it down, fatafat. We don't have time. That we can wait till your marriage. Got it?
Yes,
Huh?
sir.
Now, this same wave that we have seen there now can be represented in the form of a circular motion as well. How can a wave be represented by in the form of a circular motion? Now at time t is equal to 0. At time t is equal to 0, what is the value of x1? At time t is equal to 0, what is the value of x1? Huh? At time t is equal to 0, the value of x1 is a1. Now, this leading and lagging concept can be understood in this way. When this x1 wala wave is here, at time t is equal to 0, this is your x1 wave. Where is your x2 wave? Your
Below
x2,
the x-axis.
yes, your x2 wave is here. Phi angle behind. This x2 wave is phi angle behind it. So this x1 will always be ahead. When I say ahead, we always assume that it is moving like this, anti-clockwise, because anti-clockwise direction is taken as positive. So whatever this x1 does, x1 will reach all the points on the circle first, compared to x2, which will be following it from behind. You understand this, or this has gone above what saying bye bye? So nikal gaya, bahut ho gaya. Gone above our heads?
We understood.
Okay. Have you noted it down?
Yes, sir.
Yeah. So fast? Good. I'm impressed. Anyone noted this down? Eh?
Yes.
Then we move to our next heading. Then we move to our next heading. And what is our next heading? I'm trying to get a better diagram. If I can get a better diagram, it is going to be better, since it becomes easier for me to then make you understand this. Okay, I could take this diagram. This will serve the purpose. So this will serve the purpose. Yes, this will serve the purpose. This will serve the purpose. Now look at this diagram. This is representing a circular motion of a particle P. Do you understand this? Yes or no? In fact, this is uniform circular motion, because it is moving with a uniform angular velocity omega. Do we see this angular velocity omega? Dung, 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 dung. Huh? It is moving with a uniform angular velocity omega, and it is moving like this. Its angular velocity omega is like this. We understand this? Huh?
Yes, sir.
Now, if you look at this x coordinate of the particle, this is the x coordinate of the particle, and this one is the y coordinate of the particle. Everyone can see the x coordinate of the particle and the y coordinate of the particle? Yes or no?
Yes, sir.
Now, it will not take rocket science for us to understand that This x coordinate can be written simply as a cos omega t, yes or no? Yes or no?
Yes.
From the right angle triangle, I can write it.
Sir, it is small a.
ठीक है, I will make that one capital A. I can write it as capital A cos omega t, yes or no?
Yes, sir.
Similarly, I can write this y as capital A sin omega t. Yes or no?
Yes, sir.
That's it. So the heading of this is SHM as a projection of UCM. SHM as a projection of UCM. What do you mean by SHM as a projection of UCM? You can think of SHM motion as projection of UCM. If any equation of SHM, is given to you in the form of A sin omega t, if any equation of SHM is given to you in form of A sin omega t, you just have to imagine a particle moving in circular motion and you are taking the y projection of the particle. The y projection of the particle will always be equal to A sin omega t. Yes or no?
Yes, sir.
If you are given an equation of SHM, which is in the form of cos wave, then what will you understand? How can you understand it? You can understand it that it is nothing but a particle moving in uniform circular motion. And we are taking the x projection of that body. Do we understand this? Yes or no?
Yes.
Now, when we are taking it as the y projection, at time t is equal to 0, the particle would be here, the value of y would be 0. Yes or no? So this will be your phase 0. Do we understand this?
Yes, sir.
Then after t by 4, the particle will come here. Y will be equal to A amplitude. It will reach the first extreme point. Yes or no? So in terms of angle, it is pi by 2. In terms of time, it is t by 4. Do we understand this? After another time, t4, the particle will reach the mean position again. This horizontal line is the mean position. In terms of angle, it has moved an angle of pi. In terms of time, it has traveled a time of t by 2 from the mean to the extreme, from the extreme back to the mean. Then it will go now away from the mean position on the left hand side wala extreme. In terms of angle, if you talk, it is 3 pi by 2. In terms of time, if you say, it is 3 pi by 4. After another t by 4 time, it comes back to the mean position. It completes one oscillation. You can now call it one rotation or one revolution or whatever you call it. So whenever there is a sine wave, it is nothing but uniform circular motion. Do we understand this, what I'm telling you? If it is sine wave, this is the mean position. It starts from here. If it is a cos wave, then the mean position will be at this point. Do we understand this? If it is a cos wave, it will start from here. We understand this or not?
Yes, sir.
If it is a sine wave, it starts from here. Do we understand this? Huh?
Yes, sir.
That's it. So SHM can be taken as a projection of UCM. SHM can be taken as a projection of what?
UCM.
SHM can be taken as a projection of UCM. There is no doubt in anyone's mind how it has to be taken. We understand this, yes or no? No, yes?
Yes, sir.
I'll give you 2 minutes to note it down. Anyone having any problem, please come up. Now, since we have covered this much, we have understood this. This is just for understanding that a wave like this can be thought of as circular motion like this. It's not exactly same, but the projection is same. Now, what we can do is graphically, we can understand everything together. So you can write the heading graphical representation. Graphical representation if you want. Write it as graphical representation. So what are we going to do in this graphical representation? Remember, SHM is all about, SHM waves are all about graphical representation. The more you understand these graphs and the more you understand these sine waves, most of the 99.9% of the questions are going to come from here. Again, it may be a repetition of all the things that we have done, but why I'm doing it so many times, so that because I know that this is going to come in almost each and every topic. Do you understand this sine wave, this displacement as a function? This is the graph of displacement as a function of time drawn. Do we understand this?
Yes, sir.
This is how it is written in the form of sine wave. Yes or no? This is how it is written in the form of x, because it is x, so you cannot write it in the form. The maximum value of x is plus a on the right side, minus a on the left side. Yes or no? Nah?
Yes, sir.
Velocity. Now you can see if x is a sine omega t, velocity becomes a omega cos omega t. The wave is different. Who is leading? Who is lagging? Who is leading? Who is lagging?
Velocity is leading, sir.
Velocity is leading by pi by 2. So you can also write here, velocity leads x by a phase angle of pi by 2. Now this is the same velocity written in the form of x, y, velocity as a function of x. And you can see that it is an ellipse. We remember this, yes or no? And this is the maximum velocity a omega. You can also write when will this velocity become maximum, at which point. So everything comes here. At which point it is maximum?
Position.
At mean position. When I say mean position, when x is 0, the position is mean position, or the displacement is 0. Have you noted this down? Yes or no? No, yes. Eh? Note it down, note it down. I'll give you time, don't worry. Let me know, bacha, once you are done. X and V, the graphs. Then come the other two graphs, acceleration and force. Almost are exactly same. We just have to multiply mass with acceleration and you get force. Graph number 3, the blue graph, acceleration. In terms of sine omega t, in terms of t, it is like this. Leading, lagging, what?
Sir?
Leading or lagging? This leading x by a phase angle of pi. Remember this, yes or no?
Yes, sir.
Where is the maximum value of a?
At extreme position.
At extreme position. This graph is just a copy of the same. Everything there. Just need to multiply it by m. I'll give you 2 minutes to note it down. Okay, then, sir, we have this small question for you. Just for you to get acquainted with the type of question that you are going to encounter in an examination hall. Most of the time, which is the question based on the equation of SHM. The motion of a particle executing SHM is given by this equation. X is in meter, T is in second. What is the time period? The straightforward question. It's a straightforward answer. Yes. Hmm?
1/50
1 by
0.02 seconds, sir.
0.02 seconds, sir. That is correct, sir. How did you get it, sir? You just
Sir,
compare this
X
equation with your original equation
A sin omega t.
and you will get the value of omega. What is the value of omega? Comparing it with the original equation.
2 pi by t, sir.
What is the value given here?
100 pi, sir.
100 pi. And after this, you can easily calculate it. Yes or no? No, yes. Huh?
Yes, sir.
Comes the next question, sir. Give me the answer fast, sir. The faster you give the answer, the faster I can move on to the next question. Two equations of SHM are given by this. What is the phase difference between the two? Yes.
Pi by 2, sir. 90 degrees.
90 degrees, sir. This is in the form of sine and this is in the form of cos. We have seen it so many times. The phase difference is 90 degrees. Yes or no? No, yes. Huh?
Yes, sir.
We just go on above that saying bye-bye. Bye-bye, sir. I'm going. Well done. Next one. Everyone is understanding them or I'm just moving ahead with life? And all of you are behind. I am leading and everyone is lagging. Are we in the same phase or leading lagging is going on?
Same way, sir.
Same phase, no? Okay. Question number 3. I will not even read it. You read it, get the answer and stay happy. Particle executing SHM has something, frequency and maximum velocity of the particle. Eh? Is an answer coming from anywhere?
1 minute.
So much time. I think I have waited enough.
Sir, option B, sir.
Option B, sir, is wrong, sir. Option A, sir, is the correct option, sir. This is A and this is omega. To find the maximum velocity, you have to multiply A with omega. When you multiply A with omega, you will get 66. Only two options are possible. It could be B, it could be A. Just have to find out the frequency. How do you find out the frequency? Omega, which is 2 pi into F, is given as 220. Tongue, 110. Frequency is 110 divided by pi. And it should not give you any trouble in calculating. You don't need the exact answer. You just need an approximate answer. And the correct answer would be A. I will not go into how to calculate and how to divide. Because if you don't know it, then I can't help you out any further. Pi, by the way, my dear friends, can be taken as 22 by 7. You should not have taken so much of time. Very bad answer. Anyways, are we ready for the next one? Huh?
Okay, sir.
Okay, sir. This is the next one. Question number 4 or question number 5, whatever it is. A particle starts SHM from the mean position. Its amplitude is A. Time period is T. At the time when its speed is half of the maximum speed, what is the value of the displacement? At what displacement? Where is the speed of the particle half of its maximum speed? Should not take rocket science. This is simple harmonic motion and not rocket science. Rocket science is not in our course. Yes. I wait.
Sir, option C, sir.
Option C, sir. Thank God, sir. We got the answer, sir. How are we supposed to get this answer, sir? V is equal to omega times root over A square minus X square. Everything else is given. You have to find the velocity. You have to find the position where the velocity is half of the maximum. How much is maximum? Maximum is A omega.
A
half
omega
of the maximum is equal to
by
omega.
2.
Under root of A square minus, you can find the value of Y. Anyone can do this from here, yes or no? We understand this?
Yes, sir.
Huh? Next one, move fast. This one, question number 6 or 5, whatever it is. I think it is 6. The particle performs simple harmonic motion. The equation is given by this. The displacement of the particle is 3 units. Then what is the velocity? Any hopes of anything that looks like an answer?
1 minute. 16, sir.
16, sir. That is correct, sir. How did you get the answer, sir?
Same formula, sir.
Same formula, sir. No matter in what form that SHM is given, velocity in the form of x can always be written as, right? Why I'm writing a?
Omega under root a square minus x square.
Put the values, get the answer, and then you can stay happy. Is everyone happy?
Yes, sir.
Chalo, one question in which you have to find out everything so that I understand that you know all the terms. This is the next one. Question number 7. An object performs SHM of amplitude 5 centimeter and time period of 4 seconds. The timing is started when the object is at the center of the oscillation, that is x is equal to 0 from the mean position. Then calculate 3 or 4 things are given. You have 2 minutes to do this. Yes, tell me the answers.
Sir, frequency is 1/4.
Frequency is 1/4. You know, if I write the solution, the time period is 4 seconds. So frequency is 1/4, correct? Then?
And second one, displacement at 0.5 seconds is 5/√2.
Displacement at 0.5 seconds. How am I supposed to find this out? I just write the equation. X is equal to a sine omega t. I just put the value. The value of x, a is 5 sine of omega. How much is omega?
Pi/2, sir.
Omega is pi/2 into time is half. So it is pi/4 and you get 5/√2 centimeters. Do we understand this? Yes or no? No, yes?
Yes, sir.
You can find out the rest of the things, no? How do you find out the value of maximum acceleration?
A omega square.
To find out the value of maximum acceleration, you know the value of omega square multiplied by a. Then you have to find out the last thing, the velocity of at a displacement of 3 centimeters, and it is very easy to find out. The same formula you can apply here. V is equal to omega times root over
V
a
equals to
square,
omega in.
root over a square minus x square. Everyone understands this? Yes or no?
Yes, sir. Sir, but your voice is breaking.
Everyone understands this? What I'm saying?
Yes, sir. Your voice is a bit of lagging, sir.
Everyone got this? Let us move on.
Sir, your voice is lagging a bit, sir.
Let us move on to the next question. Okay. Anyone got this question?
Sir, your voice is lagging, sir.
Okay. Everything good? This is the next question that we are going to solve. Are you able to see this?
Yes, sir.
Okay. This is, oops, where it has gone. This is the next question that we are going to solve. Question number 8. The velocity of a particle in SHM at 2 positions x1 and x2 are v1 and v2 respectively. Determine the value of time period and amplitude. Can you do this? Yes or no? No, yes. Anyone is there in the class?
Yes, sir.
Okay. Try this one. I'll give you 2 minutes to do it.
Sir,
Waste any time.
amplitude is under root v1 square x2 square minus v2 square x1 square by v1 square minus v2 square, sir.
So basically what formula you need to use is v square is equal to omega square into a square minus x square. I just gave you this question so that if this question comes in the exam, you know the result and you can straight away put the result. So I will have v1 square will be equal to omega square into a square minus x1 square. You will have v2 as omega square into a square minus x2 square. Do we understand this? Yes or no? Anyone understands this?
Yes, sir.
Now from here, you can easily find out the value of omega, time period and a. I'll just give you a result. The value of omega that I have is under root of v1 square minus v2 square divided by x2 square minus x1 square. Once you have the value of omega, you can find out the time period. Time period is simply 2 pi by omega. The value of amplitude that I am having is v1 square x2 square minus v2 square x2 square divided by v1 square minus v2 square, the root of this entire thing. Everyone got the answers for this one? Yes or no? No, yes.
Yes, sir.
No problems with this one?
No, sir.
Okay, great. That will take us to the next problem. And the next problem looks like this, which is coming on your screen now. And just be patient and see how this problem has to be done. This is the problem, question number 9 or 10. I have forgotten the number. Let me call this as question number 10.
It's 7, sir.
A particle of mass 2 kg is moving on a straight line under the action of a force F is equal to 8 minus 2x Newton. It is released at rest from x is equal to 6 meter. Is the particle moving simple harmonically? That is the first question. Find the equilibrium position of the particle. Write the equation of motion of the particle. That means the value of x as a function of t. Find the time period of SHM. So they have given the answer for the first part in the last part, that the motion is SHM. You have to understand why it is SHM and why it is not SHM. Anyways, you have a question here. I give you 2 minutes to solve it. Get the answer and stay happy. Okay. So the first thing first, you have to find out the equilibrium position of the particle. What do you mean by equilibrium position? Huh?
Force is equals to 0.
That's it. Do it and you will get the value of equilibrium position.
Sir, what is the answer for first one?
It is a simple harmonic motion. No doubts about that.
Sir, we can conclude that, but what is the proof?
What is the proof? This is the proof that I am saying that it is simple harmonic motion. Don't worry, I'll tell you the proof. The only difference it makes it just because you are looking at the force like this, but that does not make any difference. For equilibrium, Force has to be 0, yes or no?
Yes, sir.
That implies what is the value of x?
X equals to 4, sir.
X is equal to 4 meter. At x is equal to 4 meter, the particle has an equilibrium position. Now, if you look at the diagram, and if I draw the diagram of this body executing SHM, it has been given that it is released from rest at x is equal to 6. This is x is equal to 6. From here it is released at rest. So that means it becomes your extreme position. Yes or no?
Yes, sir.
That's it. So if this is your extreme position, what is your amplitude?
2, sir.
See, the simplest question in the entire universe. The amplitude is 2 meters. Now, it is released from rest from this position. So at this position, time is 0. Yes or no? No or yes?
Sir.
Now, you just need to write the equation. How will you write the equation? To write the equation, you must know the value of omega. Yes or no? No or yes? How do you get the value of omega? Remember that old formula, omega is root over k by m. Do we remember that formula?
Yes, sir.
That's it, sir. What is the value of mass m?
2 kg.
What is the value of k? F is equal to minus kx, my dear friend. Do we understand this? Yes or no?
Yes, sir.
K is 2. So the value of omega becomes 1. You know omega, you know amplitude, you know the SHM is starting from the extreme position. What will be the equation of this SHM? X is equal to 2 cos omega, omega is 1 t. The problem is, whenever we have written the equation of SHM, we have always assumed that your mean position is at the origin. Here it is not at the origin. Do we understand this?
Yes, sir.
Here it is not at the origin. Now, if you want to write the equation from this origin O, you want to write the equation from origin O, how will you write the equation? There is no physics involved here. It's only maths, our favorite maths. So your x will simply become, x will be equal to, from the origin O. This is equation is from the mean position. Mean position is x equal to 4. So from the origin, the equation becomes like this. Do we understand this, or this has gone above our head saying bye bye? Bye bye. Up till now, all the equations were written from the origin, and your mean position was at the origin. Here, your mean position is somewhere else. You're writing the equation from the origin, but displacement is always given from the mean position. So you write the displacement from the mean position, and then you add or subtract the position of the origin from the mean position. We understand this? Yes or no? No, yes.
Yes, sir.
The only thing that would have confused you is this 8. This 8 only comes because the origin is not your mean position. That's it. Nothing else. You understand this, or this has gone above our head saying bye bye? So this is the equation of an SHM. Shall we move ahead in life? Huh? Shall we move ahead?
Yes, sir.
Then you said, sir, why it is SHM, why it is not SHM. So comes the next question, my dear friends. Which of the following equations or functions? First function is sine square omega t. So the equation of SHM, if you write the equation of SHM or equation of this value, it will be x is equal to sine square omega t. Does this represent the equation of SHM? X is
No, sir.
equal to sine 2 omega t. Does this represent the equation of SHM? X is equal to sine omega t plus 2 times cos omega t. Does this represent the equation of SHM? And the last one, x is equal to sine omega t plus cos 2 omega t. Does this represent the equation of SHM? 4 equations are given to you. You have to tell me which equation represents simple harmonic motion and why. Oh, why not?
Third one is most likely to be.
Do you understand the question? Yes or no? No, yes. Huh? You understand the question?
Sir, option 2.
Option 2.
C or B, most likely.
Why not option 1? Why not option 3? Why not option 4? Huh?
Sir, as sine square omega t is not like, it's not like sine omega t, graph of sine square omega t is.
How do you find out where SHM, whether equation is SHM or not? Now, the test that we do, question number 11, for any equation to be an equation of SHM, your acceleration should be proportional to minus of x. Yes or no?
Yes, sir.
That's it. If you can get that relation, acceleration is proportional to minus x, that equation will be equation of SHM. So you differentiate it once, x is equal to, first equation, x is equal to sine square omega t. You differentiate it once, what do you get?
2 cos omega, 2 sine, 2 sine omega t cos omega t.
2,
Sine omega t.
1 omega will come out first of all. Yes or no?
Yes, sir.
1 omega will come out, and then you will get sine of 2 omega t. Yes or no?
Yes, sir.
Then you differentiate it once more. What do you get?
It is 2 omega square cos omega t. Sorry, 2 cos 2 omega t.
2 omega cos 2 omega t. Yes or no?
Sir, omega square.
2 omega square cos square omega t. Now you can write this sine square omega t as
1 minus
in terms of cos 1 minus 2 times 1
sir
minus
1
2
minus 1 minus 2 cos omega square 2 cos 2 cos
2 cos
2
2
omega t.
omega t by 2. Yes or no?
Yes, sir.
Now you are getting your acceleration in this form.
Sir, 1 minus cos 2 omega 2. There will be no 2, sir.
Oh, sorry. Yes. 1 minus cos 2 omega 2 by 2. Your this is in this form. Your x is in this form. Can you write it? A in the form of x?
No, sir.
You cannot write because 1 omega square. You cannot write it. Yes or no?
Yes, sir.
Therefore, this does not represent the equation of an SHM. Do we get this?
Yes, sir.
Now, similar test you can do with equation number 2. In equation number 2, you will find out what? That your acceleration can be written in terms of y, and therefore that is your equation. Yes or no? Similarly, when you do the test for the third one, you will find out that acceleration can be written proportional to minus of y. Once you move on to the fourth one, you will find out you are not able to write it, and therefore these two equations do not represent simple harmonic motion. Do we understand this? Do we understand this?
Yes, sir.
Everyone understand this?
Yes, sir.
So that's it for today's class. That's it for today's class. We'll meet in the next class and we will go ahead with the next topic. In this, we will be dealing with mechanical energy in the next topic. Okay? Take care. Everyone understood what we have discussed today?
Yes, sir.
Okay. So we'll meet in the next class. Take care. God bless all of you. Bye bye.